We are starting lesson 2 task regarding factors. Okay, with our instructional task, this purpose of this task is for students to deepen their understanding of factors and multiples of whole numbers. This is a classic mathematical puzzle. Often it is stated in term of 100 lockers. So students have to make the connection to factors and multiples to solve it. In this version of the game, students can just go through all the rounds of opening and closing locker doors and observe after the fact that there is a relationship between the factors a locker number has and whether it is opened or closed at the end. The task will provide Macy with an excellent opportunity to engage in MP7, look for and make use of structure, or in SMP8, look for and express regularity in repeating reasoning, and describe the pattern as she imagines students opening and closing the lockers. Because the total of lockers is only 20, we will have 20 lockers. Students might answer the questions without thinking about the underlying reasoning for this answer. In the first question, for an example, a student may say 1, 4, 9, 16 are still open because I tried it out and those were the ones that were left open. If a student goes this route, the teacher can steer the conversation back to factors by asking the student if they notice anything special about the number of the lockers which are still open. So this activity is going to give me as the teacher a great opportunity to ask open-ended questions regarding factors. We actually have 20 lockers on this task. So Macy will have that in front of her. There will be 20 students that accommodate each locker, one per each student, okay? In Mr. Norman's 4th grade class, which is her teacher's name. They're all playing a game in the hallway that is lined with 20 lockers in a row. She don't actually have 20 lockers lined up in a row in her classroom or in the hallway because she's in elementary school. But in middle school, you will have lockers lined up in the hallway. So the first student starts with the first locker and goes down the hallway and opens all the lockers. So Macy will actually open every single locker up. So I want Macy to put an O at the bottom of each locker. So she knows that she has went and opened every single one of those, okay? Being the second student, Macy's actually going to be every student since we're tutoring you. So I'm going to help you out. So I was the first student, Macy's the second student. Macy starts with the second locker and goes down the hallway and shuts every other one. Okay? So when you see the task of starting with the second locker, you're going to fill in that bubble which represents a closed locker.
Okay.
Okay? So every other one, every other one from the second, which will be what numbers, Macy?
It will be pretty much all the even numbers.
All the even numbers. You're exactly right. So every other number starting with the second locker will be all the even numbers. Okay? So Macy, with this task, I want you to note in that question that you closed all even numbers from 1 to 20. Okay, so I'm going to be the third student. Okay, the third student stops at every third locker and opens the locker if it is closed or closes the locker if it is open. So I'm going to stop at every third locker. Okay, so we're looking, and on top of that, Macy, I want you to note 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20 were the numbers you closed. Okay? So, I'm starting at the third locker. At every third locker, and opens the locker if it is closed, well, that one's open, or if it is closed, or closes the locker if it is open. So I'm going to close number 3. Okay. 1. Now number 6 is actually closed because it's an even number. So I'm going to reopen it. I'm going to reopen number 6. Okay. So 9. It needs to be closed. 12 needs to be open. 15
needs to be closed.
Needs to be closed.
17 needs to be closed.
No, that's not the third one. 18 is the multiple of 3.
So that needs to be opened.
So this needs to be opened. And then we're at the end. So we found out that the third student opened 6, 12, and 18, and then they closed 3, 9, and 15 that you actually opened. The fourth student stops at every fourth locker and opens the locker if it is closed, or close the locker if it's open. Okay, so Macy, so you're at number 4. So you're doing the multiples of 4. So you're reopening 4. You're reopening 8. You're closing 12. Hang on, let me write this down. Okay. You're opening 16. And you're opening 20. Now, is 20 a multiple of 4?
Yes. 4 times 5.
Okay. 4 times 5. So we opened 4, 8, 16, and 20. And we closed 12. Correct? Okay. Now the process will continue until all 20 students in the class has passed through the hallway. Now, after we're on the 4th student, so the 5th student.
So it will be every 5, and if it's opened, you would close it, and if it's closed, you would open it.
So this one's open, correct?
Mm-hmm.
So I would close 5.
And you would open 10.
I would open 10.
You would open 15.
I would open
And
15.
you would close 20.
And I would close 20. Okay. So now the 6th student.
I would close. I would close number 6.
You would open 12.
I would open 12. I would close 18. That's all.
Okay. Okay, the 7th. So I would start at 7. I would close 7, correct?
Mm-hmm.
Then I would go to 14 and I would open 14. And that would be the only 2 that I would do, correct?
Yeah.
Okay. So we would have the 8th.
8.
Close 8.
I would close 8.
And close 16. So we would not have anything open there. 16 and 8. The 9th student. So we would open 9 and then open 18, right?
Uh-huh.
Okay, the 10th student. You would close 10.
Uh-huh. And you would open 20.
Good job, Macy.
Then there's no more left to go.
You would open 10 and close 20. Okay. Then on the 11, you would close 11, correct? And 12, you would close 12. $13, you would end up going through 13 through 20 because you're only going to hit it once. So you're going to close 13. You're going to close 14. You're going to close 15. You're going to open 16. Close 17. Close 18. Close 19. And close 20. So now we've went all the way through. So now let's answer our questions in our task, okay? Which lockers are still open at the end of the game? Which lockers are open?
1, 4, 9, and 16.
Okay. We're going to, how do you explain your reasoning in that? 1,
Because it's an open circle.
4, yeah, we did do a visual. 9 and 16. Those were the opened lockers. Okay? Because Macy tried it out and those were the ones that were left open. Do you notice anything special about the numbers of the lockers that were still open? Try a larger number of lockers, say 50 or 100, and repeating the game can also help students look for a pattern. What kind of pattern is there, Macy? Is there a pattern?
Yeah, it's odd, even, odd, even.
You're exactly right. Odd, even, odd, even. Great job. So you've seen the pattern there. Okay, question 2. Which lockers were touched by only 2 students? Explain your reasoning. Touched by only 2 students.
Oh, well that means that you only have like it should be circled with 1 or
By 2 students, it would have 2 circles, correct?
Because
it's
the
asking.
circles that mean that they closed or opened.
Yeah, but they touched it. The student touched it.
Yeah.
Which lockers were touched by only 2 students?
Yeah. So it would be 2, 3, 5, 7, 11, 13, 17, 19. Because one person opened it and one person closed it.
Okay. The lockers that were touched by only 2 students are all what kind of numbers?
Are all
Is it prime numbers?
Oh, they are all prime numbers.
They're all prime numbers.
Wait.
Since prime numbers only have 2 factors. Prime numbers only have 2 factors.
They're only prime numbers.
So they're 2, 3, 5, 7, 11, 13, 17, and 19. So those are all the prime numbers. Okay? The third question. Which lockers were touched by only 3 students? Explain your reasoning. The lockers which are touched by only 3 students are what of the prime numbers?
It would be 4. It would be then it would be 4.
These numbers have have 3 factors. In our case, there are 4 and 9.
Yeah.
4 has 3 factors, which are what? What is the factors of 4?
1, 2, and 4.
Good. So
and then
they're all the squares of a prime number. Okay? They're all squares of a prime number. So, question D. Which lockers were touched the most?
18 with one of the 20, 18, and 12.
How many factors does each one of those have, Macy? Can you find, let me get the expo marker. Each one of those numbers has the same number of factors. Try to find the factors of 12, 18, and 20.
I'll have 3.
They all have how many factors?
3. I found 3.
How many factors?
Like numbers.
The factors are what?
Oh, yeah.
Let's review.
So it'll be 1, 12, 2 and 6, and 3 and 4. For
How many factors are in each number?
6.
6. You're exactly right. The lockers which are touched the most are those lockers whose numbers has the most factors. So those 3 lockers have the most factors, which is total 6. So they were each touched 6 times. Okay? So this activity actually gave us some insight on the factors of numbers, and also gave Macy some experience using lockers and prime numbers, and learning a little bit more about the squares of prime numbers, dealing with factors within our task. This actually concludes our task section of finding the factors of numbers.